Good morning, everybody. My name is Mario Veruete. I'm a mathematician and patent attorney. I'm delighted to take part in this conference as a presenter and be able to show you Patentstar, a Wolfram expert system for the European Patent Office. Well, I have to say that this is a joint work with Gianni Moslan from Straco in Geneva, Switzerland. And he's also a presenter in the conference. He's presenting a conference entitled 4 Points in a Three Universe on Friday. So don't hesitate to see what he's going to present. Actually, he's going to present C-Star, which is the scientific engine behind the Patentstar software. So I'm going to present this. So Patentstar is essentially based in intelligent agents combined with native Wolfram entities and also entities defined by user. And all this together will allow us to interact with structured patent databases. So the goals in this project were to understand technological landscapes. This can be difficult because, science and technology is always evolving. And we have to find a way to treat this huge amount of information indeed. So another goal we have to address is to assess patent similarity beyond the traditional keyword matching in order also to make nuanced decisions about patentability. We want to also transform raw patent data into actionable insights for decision and support. And something not less important is to make computable any kind of data. It can be molecules, countries, concepts. For those who are already familiar with Wolfram technologies, you know that this is part of the philosophy and the essence of the Wolfram language. Okay, so let's talk about patents. So what is a patent? Well, a patent is a legal right granted to an inventor, and there are three main um, characteristics of a patent. A patent is given to an invention which is novel, non-obvious, and industrially applicable. When a patent is granted, it gives exclusive control over its use, the use of the invention, and the commercialization for a limited time, usually 20 years. Well, why patents are important? Well, they are a way to reward creativity, secure investment, and protect the intellectual effort of inventors. It is also important at an industrial scale because we are familiar to technology transfer. This also allows to promote competition through disclosure and also makes measurable sets for companies. Finally, it's also important at a societal scale because it fosters innovation ecosystems by transforming knowledge into structured, searchable information. The typical structure of a patent is this one. You have some figures, you have an abstract. So for example, here you have a patent from Nikola Tesla, one of the greatest inventors we know of today, about a very nice valvular conduit. You can see it was patented on 1920. And the typical structure of a patent, you have some figures, you have an abstract that describes the essence of the invention, a set of paragraphs which are called the description, and at the end usually you have the claims. So that's what I claim is. It's a set of usually 10 to 20 paragraphs that describe the legal protection of the invention. Well, let's talk about patent databases. Patent databases represent one of the most complex and structured information repositories, both in the legal and technical domains. They contain bibliographic information, for example, who is the inventor, who is the applicant, what are the dates where the patent was filed, what's the technical content. As we already said, there are some drawings, description, claims. There's also a system of citation networks, so we can retrieve the innovation process, sort of speaking, and also some legal metadata, which are important for us patent attorneys. So the main idea here was to exploit the entities that are already available in Wolfram to represent the chemicals, for example, inside a patent, but also to use them to create a conceptual, a symbolic way of representing patents. So for example, here, usually a patent is identified by a unique number, which in this case is what we call the publication number. And inside this entity, we have many different type of information. For example, I can ask for the publication date. For those who are already familiar with date objects, you can recognize that this is a date object, which makes it computable. We can ask other information, for example, here, who is the applicant, what are the country, the addresses, the name. So you can see there are many informations we can exploit, or we can use to try to find some insight about tendencies in innovation, or we want to make a patentability analysis. So we have to make sense of all this information. We can also see, for example, what's the title and the description. Usually it's a number of paragraphs. You can see here a data set containing the paragraph number and the text inside the paragraph. Okay, so I'm going to make a live demo of Patentstar. As I told you before, Patentstar uses the sister engine. So it's our artificial science engine developed in collaboration with Jenny Mosselin. As I told you at the beginning of the presentation, he's going to present on Friday about C-Star. Okay, so here I have Patentstar. I click in this button to launch Patentstar. Patentstar is going to connect to the patent database. Here, for demonstration purposes, this is just a small sample database. Now, yes, Patentstar, as you can see, it displays a set of palettes that provide access to various tools. Let's start, for example, using the chatting palette. As you can see here, we can chat with the database from the EPO, European Patent Office. A similar thing can be done with other offices like the United States Patent and Trademark Office. Here we have chat with an LLM, large language models, and also chat with friends. You will see that this connects actually to Wolfram Alpha. Okay, so let's start with chat with EPO. I want to make a query to query the database. And we can, for example, ask in some domains like biology. For example, I can say, I'm looking for patents that contain the word virus in the abstract. I submit the query, and I should see a set of patents. Well, in this example, there are only 4. If I click in this button here, find the here under list of patents, I can see some information. So this is the first patent in the list. As I told you before, we can have access to the abstract. Let me make this a little bit more in the center. To the abstract, the description and the claims of the patent. And we can do that for all the patents in the list. Well, that's nice. But we can also, for example, try to see geographically the distribution of the applications. As you can see here, we have some Korean application, United States, and Italian. We can make this in bubbles to visualize easier the distribution, or try to draw the density. Well, here we have not so many patents, so the density looks a little bit weird, but here it's clearer. Okay, so that's a first insight about the geographic distribution of the patent applicants of this particular query. Great. We can do also, for example, here, the histogram of the number of patents in this list as a function of the classification classes. So the inventions are classified by the European Patent Office or the United States Patent Office into classes. Those classes corresponds to different domains of technology, technological domains with several subdomains. So there are actually many of those classes, more or less 10,000 classes with all the subclasses that exist. So the patent office really makes a great job by classifying those. And it is important because when you are looking for, when you are trying to do a patentability analysis, you have to check among everything that exists, let's say just all the patents that exist in the database, you have to find those who are close or related to the invention you want to study the patentability. So you have to filter by class. It's easier to find what you are looking for when you filter by class. So this is important. We can also draw a time histogram of filed patents. Well, as you can see here, those are all quite recent in 2022. So this is over the year 2022. But if we have more patents, we will see a time distribution that can vary, find some tendencies. Maybe in, I don't know, in the 60s, there was a big tendency for a particular type of technology, then it becomes completely obsolete, or we can see several types of phenomena. As you can see, you can sort the results by country, number of classes, date, direct date. Let's try to analyze a particular patent here. For example, let's take this one. When I click in the patent number, what I'm going to ask to Patentstar is to create a summary and an analysis of the main technologies, the three main technologies in the patent. So as you can see here, I get as a result this tab view. This is the text of the abstract. And here there's an agent which took the content of the patent and analyzed the main properties of this patent. So for example, here, this patent is talking about the treatment of motor function disorder. It also uses viral vectors and targeted disorders. The patent addresses specific motor neuron disorders, including spinal muscular atrophy, amyotrophic lateral sclerosis, spinal bulbar muscular, etc. Okay, so that's the main content of the patent, but we also want to find what are the main innovations of this patent. So the three main novelties in this patent are the composition for motor functions disorder, the self-complementary adeno-associated virus vector, AAV, and targeted treatment for specific disorders. Um, we have another visualization here, which is the graph of main entities of the patent. Here, for example, it is the adeno-associated virus vector, the spinal cord injuries, motor disorders. Of course, as you probably know, there are many layouts that are available in the Wolfram language. You can choose the color, you can choose the layout. And something that we also like is to read quite often the claims, because the claim, as I told you before, they define the legal protection of the invention. So that's the most important part of the patent. And here we have 15 claims. We can read each one. We can make a word cloud of the claims. We can see here the AAV appears pretty often, virion, recombinant, to get just an insight of the patents. And also with the description, the word that appears the most is the acronym AAV. Great. So that's for this particular patent. We can also click here to visualize the graph of patent classes. So there are two main patent classification. You have the International Patent Classification, IPC, and you have the Cooperative Patent Classification, CPC. They are similar in a certain sense, but they have some differences. So as you can see, this particular patent is classified into these classes, so they can be identified by a specific identifier. And here you have some class with subclasses associated to that particular class. So this is also useful to get an idea of what are the technological domains in which the invention, to which the invention belongs. Great. Now I can, let's say, for this patent here, if you remember, there was a list of pathologies, and there was in particular one, which is amyotrophic lateral sclerosis. If I want to know a little bit more, I can chat with Wolfram Alpha. Here, for example, I can ask amyotrophic lateral sclerosis. This is going to send that request to Wolfram Alpha, and here in the French chatting session, we recovered the Wolfram Alpha output. So here's the definition of that disease: neurodegenerative disorder characterized by progressive degeneration of the motor neurons. Medical codes, medical specialty, non-invasive ventilation, some statistical data. You're probably already familiar with Wolfram Alpha, but we thought it was important to make it easily available to work with several patents at the time. And also, if you want, for example, ask to an LLM something, for example, here we talked about amyotrophic lateral sclerosis. Here I can ask for what are the treatment for amyotrophic lateral sclerosis. And this is going to send that to the LLM API, recover the answer, and we should see an answer here on the left. So I can get the information of the medications used for this disease. You can see here we have actually a chat. It's the same for the EPO chat, the LLM chat, or the Wolfram Alpha chat. We take into account the timestamp for which we ask the question, and we can retrieve everything across the time. talking about time, I have just 6 minutes. So let me just present you something interesting here. If you are familiar with Wolfram Alpha, you know we can ask many different informations about different topics, and in particular about patents and research. For example, here we can ask about what is the research and development spending in Europe, 1.3 billion per year. We can ask to compare that with the United States or wherever. So that's also a very, very useful tool. Great. Thank you very much for your attention. I will be more than happy to answer any question you may have. Thank you. So the first question is the code for Patentstar released as open source? I'm sorry, the answer is no. We may try to consider that later, but for the moment, it's not the case. Patentstar can also, yeah. So the question is, do those Patentstar also look for expired patents or rejected application? Yeah, the answer is yes. We can retrieve all the legal information, all the procedure information about the patent. And I think those are the only two questions. So thank you very much again for your attention. And don't forget, on Friday, Gianni Moslin is going to be presenting Sistar, the artificial intelligence engine behind Patentstar. Thank you very much.